Okay, so for problem 5, we're asked to implement the expression, this one, with regular gates and then only use NOR gates. So first, to make the regular circuit with regular gates work from the inside out, so we know we have inputs X, Y, and Z, and we can see that we have a Y bar and a Z bar. So give those two invert gates, and then you can see that these three variables are ORed together. So we make an OR gate and have each variable be an input. So X is input, Y bar is an input, and Z is an input. And then we can see that all of these terms are ANDed together. So we have that big term ANDed with Z bar, and then this is our final answer. And then to make it using NOR gates, if you go online, you can look up NOR equivalent gates or NAND equivalent gates. He might ask for one or another, and you'll find something that looks like this. This is just saying that this is equivalent to this. So if you put X in one as the input in this one, you'll get a Y out on the other side. Same thing. If you put X on this side, you'll get Y out. X bar. You get X bar out. And the same thing here, X, Y. You get X ANDed with Y. Same here. If you put X into the input, then you get, like, if you look here, this is an inverter. So you get X bar out here and Y bar out here, and then these two are NORed together, which is the same thing as just X, Y. And lastly here, an OR gate, X here, Y here, then you get X NOR Y through another, and then you put this through the inverter, you just get X or Y. So once you have your problem, your regular circuit like this, I would just box out each gate that you made and make their NOR and replace them with their NOR equivalents. So first we would have X, Y, Z. So first, to make the inverter with the NOR gate, you just connect both inputs to the same variable. Same thing with Z. And then for a triple input OR gate, first we need to realize that that is the same thing as two OR gates cascaded together like this. And so this requires you section these two off and then replace those two boxes with their NOR equivalents. And then lastly, same thing with this one. So once you've done that, you should get something like this monstrosity. And then this would be your equivalent. These two would be equivalent. So if you look here, these two are our inverters, and then this is our first OR gate. Remember that we had to cascade two gates together. So this is our first OR gate, and then this is our second OR gate. OR gates. And then finally, this is our AND gate. But if you look at the problem, it tells us that we need to use as few gates as possible. And this obviously uses a lot of gates. So what can be done about that? So if you go through and analyze the circuit, so Y bar, Z bar, and then X, Y bar go in, X, NOR Y bar, and then through the inverter, X, Y bar, X plus Y bar. It adds another bar, and those two just cancel out. And then here, X plus Y bar go in, and it's all NORed with Z. Now we have X Y bar plus Z, and then that's NORed to get those are NORed together, and then goes through another inverter. So we're left with this again, and then another inverter, and it puts the bar back on. And then if you look at the bottom line, Z goes through two inverters, so we're just left with Z again. So our final output should be X plus Y bar plus Z, and all those are NORed together. And then finally it's NORed with Z again. And then using this expression, we can make a even more simplified version, like so. So again, just like regular, we need making a regular circuit work from the inside out. You can see that we have one Y bar, so we need an inverter for the Y. So with an OR gate, make both inputs the same variable, and that would be your Y bar. And then see here, this is X plus Y bar plus Z all NOR together, and we know how to do that. That's just a 3-input NOR gate. So X, Y bar, and Z go in. And then once again, all of that is NORed with Z again. So one final NOR gate. So we have the output of the first NOR gate, which is X plus Y bar plus Z NOR together. And then finally, that is NORed with Z, giving our final output as this. As you can see, they are equivalent. And this circuit here is our most simplified version. As you can see, it only uses 3 NOR gates compared to all these. And that's